Today's lesson is going to be about the difference between the slope of parallel lines and the slope of perpendicular lines. So when you think about parallel lines, these are going to be lines that are never ever going to intersect. So if you've got this line here and this line here and they're never going to intersect, think about what their slope is going to look like. The rise to run, the ratio of rise to run, rise to run, rise to run. They're going to have to be exactly the same. If they are never going to intersect, if they're going to continue on like that, they have to have the same slope. So when you're looking at a set of lines and you're trying to determine which two lines are parallel, the easiest thing to do is find the slope of every line. So you can either rise to run, so count vertically up, and then over, so change in y over change in x. So let's look at that. Let's do that for these two. Instead of using the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1, I'm just going to take point here, and go 1, 2, 3, 1. So blue has a slope of 3 to 1. Red has a slope of 1, 2, 3 to 1. And green has a slope of 1, 2, 3, 4 to 1. So you can see that line blue and line red are the set of parallel lines. So if we're going to say like line blue is parallel to line red. Okay, and then in this one here, we're going to do rise to run again. So rise for blue, 1, 2, 3, 4, 5, 1, 2, 3. So line blue has a 5 to 3. Line red, 1, 2, 3, 4, 1, 2, 3, 4 to 3. And line green, 1, 2, 3, 4, 1, 2, 3, 4 to 3. So you can see red is going to be parallel to green. So when you're looking for parallel lines, they have to have the same slope. If you take a look at numbers 3, 4, and 5, you'll notice that it just says y equals negative 5 and y equals 3. 4 says y equals 0 and x equals 1. And 5 says x equals negative 4 and x equals 1. These are vertical versus horizontal lines. When you have y equals negative 5, that means your y value is going to be negative 5 every single time. So if you're looking at like an ordered or a coordinate plane and you're looking at negative 5, so that's down here, your y value, so go x amount, whatever, but you're always going down negative 5. So over however many, down negative 5. Over however many, down negative 5. When you see y equals negative 5, that's a linear equation for a horizontal line. So the same thing with y equals 3. That would be over however many, up 3. Over however many, up 3. Over however many, up 3. So when you see y equals 3, that is another horizontal line. So these are a set of parallel lines. These two are parallel. So now let's draw that coordinate plane again and take a look at y equals 0. So you're going over however many and up 0. Over however many and up 0. You're landing on that x-axis every single time. So over however many up 0. So here I'll do it in red so you can see it. So that's this line right here. And then x equals 1, you're going over 1 every single time, but up however many. Over 1, up however many. Over 1, up however many. When you have x equals a value, that is a vertical line. So here, these two are not parallel. These two lines are not parallel. You see line red, which is y equals 0, is that horizontal line on the x-axis. X equals 1 is a vertical line. These are actually going to be perpendicular to one another. So if you have the same, either x equals negative 4 and x equals 1, they're going to be parallel. But if one of them is a horizontal line and one's a vertical line, then they're going to be perpendicular to each other. So let's just look down here at perpendicular lines then. So if you kind of think for a moment about lines and for lines to be perpendicular to each other, one line has to be going like this, but then the other line has to be coming this way. So if you think about the slope and you think about rise to run, well, in order to cut that line back the opposite way, you're going to have the opposite slope. And if you think about like a slope, okay, so say that's like a slope of 5, okay, and I have a slope of -5, it's going to kind of look like this. Those are not perpendicular to each other. So somehow we have to swing this line. Not only does a perpendicular slope have to be negative or the opposite of what the one line is, but we also have to kind of swing this way a bit and this way a bit. So what we're going to see here is in order to have perpendicular lines, not only do they need to have that opposite slope, not only does one of them need to be going this way and one of them need to be going this way, okay, so those two have opposite slopes, but their slopes themselves, because if you had a steep slope of 5, like in this problem here, oops, in this one here, if you had that steep slope of 5, a -5 is not going to give you perpendicular. That is not a right angle right here. What you need is to have not only the opposite, but the opposite reciprocal, okay? Remember, the product of their slopes is always going to be -1, so opposite reciprocal. So if you have a slope of 1/2, its opposite reciprocal is going to be -2/1, okay? So when you're finding your lines that are going to be perpendicular to one another, you have to do the same thing we did with parallel lines. Find the slope of each one. So let's look at line green here. So I'm going to do slope here is 1, rise 1, and then we're going left, so it's negative. 1, 2, 3, 4, 5, 6. So line green has a slope of -1/6. Blue, all right, so rise 1, 2, 3, 4, 5, 6 over 1. So blue has a slope of +6/1. Red has a slope of 1, 2, 3, 4, 5 over 1. So red is 5/1. So you can see that line green is perpendicular to line blue. That is the symbol for perpendicular. You could do the same thing with this other one over here. You just count your slopes. So rise 1, 2, run 1, 2, 3, 4. So blue has a slope of -2/4. That's a 2, which is -1/2. Green is rise 1, 2, 3, 4, 5. 1, 2, yep. 1, 2, 3, 4, 5, 6. 1, 2, 3. So green is 6/3. And then red here is 1, 2, 1, 2, 3, 4. Red is rise 2 to, it's a -2/4. So we have a -1/2. We have a slope of 2. And we have a -1/2 again. So in this one, actually, line green is perpendicular to both blue and red. Blue and red are also parallel to one another because they have the same slope. So now if we look down here at the equations and we think about what we had just learned up here with the vertical versus horizontal, if you have the same equation, like x equals -8, x equals 7, those are going to be parallel lines, so they are not perpendicular because these are two, in number 10 is the one I'm talking about, these are two vertical lines. But in numbers 9 and number 11, you have x equals -2, okay, and y equals 8. So x equals -2 is going to be like over here, and then y equals 8 is going to be this way here. So those are definitely going to be perpendicular. X equals 1, y equals 3, definitely perpendicular again. Okay. So, can't spell. Perpendicular. There you go. All right, so parallel versus perpendicular. Parallel lines have to have the same exact slope because these are two lines that are never going to intersect. Perpendicular lines have to have a slope that is opposite and reciprocal to each other.